Hello everyone, True Zero Emissions here. Okay, I don't even know how to say this, and I don't actually believe what just happened, but I'm going to share my experience with you. Since I was a kid, I was told that you can push two magnets together that are repelling each other, and if you hold them there long enough, they'll stay. I may have misunderstood that, but because that was said to me starting at a very young age, and I'm talking about 2 and 3 years old, I just now took these two sets of magnets, and I have to figure out a way to show this to you, but I just flipped the polarity on one of these magnets. I flipped the polarity on a magnet. Have you ever heard of such a thing? I did not use electricity to do this. I'll show you what I did. I'm going to show you right now. I have to wonder if this is part of what Don Smith makes his system work. Because right now at the moment I'm extremely puzzled by my results today, my test results. So at the end of the night, I just pushed two magnets together, and when I did that, when I pushed two magnets that did not want to be together, and I pushed them together, first I put my safety glasses on. See how these are repelling each other? They're repelling each other, right? So the other side will attract, right? This is attracting, right? Oh, that hurt. I have to be careful, sorry. Gosh, I'm tired right now. I'm not supposed to be doing this when I'm tired. It's so easy to make a mistake with magnets. I just pinched my finger, but I don't see anything, it just hurts. Okay, I'm going to show you what I did. I hope it's in focus. So it was in repel, right? Now first let's look at this magnet. Let's start by looking at this magnet. This magnet, let's see what size, what polarity this is right now. So I'm hoping you can see this. It's reading south, which means this side is north, right? And this is neutral, and then south again, south. So it's reading south here. Now watch this magnet, right, south. So if I take this magnet off, it's still reading south, which means this side is reading north, right? Now I'm not changing the direction of the magnet. I'm going to leave it the way I took it off. So right now it's reading south. I'm going to put it up against these magnets here. Let me see which way these go. Okay, they go this way because it's attracting. It should still read south. Okay, it still reads south. That's an S. Watch what I do right now. Watch this. I'm calling it flipping the polarity, right? Now I'm holding this tight because I got to make these stay together. Okay, I'm going to push these together and force it. I'm forcing this. Okay, I'm holding it. Now watch what happens. Okay, one magnet stayed. One magnet stayed there. You see that? That magnet stayed. I'm going to take it off, and let's read the polarity right now. Let's read it on this side. It was south, right? Now it's north. How did that just happen? Have you ever heard of that? I think there's something here. I'm going to thank Don Smith. I know he's not here in body, but did that come from Don? I mean, I was putting everything away. And I had zeros on everything. I got 1 volt out of my generator tonight, and nothing was happening on the magnet. And then I pushed the 2 magnets together as hard as I could, and one stayed, and I noticed the polarity shifted. Look at that. That means this side's south now. This side's north. We can keep flipping this too. We can flip it again. I don't know what this means. I don't know what I can do with it. Okay, so it sticks there. If I flip it over, it still sticks. But let's flip it again. That's interesting. It sticks both ways. Whoa. That's not, I don't think that's normal. How could it stick both ways? I don't understand that. Sorry. Now this is the one we flipped the polarity on. I'm going to set that down. I'm going to put south down. I want to see if another magnet will stick on both sides that we haven't done the polarity shifting to. I want to see if it sticks on both sides to this magnet. No, look, look, this one's repelling. Whoa. This one's repelling. Now the other side will attract. Yes. Wow, this is amazing. I mean, I'm looking for books that can teach me more about magnets, and I haven't seen anything. What does that say? Now this magnet, this is the one we flipped the polarity on. It sticks on both sides. Oh, wow, look at that. It started to repel for a second. Now it's attracting, starting right there. At first, it started to repel, at first. Why is it that I cannot learn anything about magnets? Now it's pushing away a little bit. Now it's attracting. Something happened to this magnet. Something's different about this. Because I pushed it into this. I don't know what this is, everyone. All I know is I'm noticing it. This is what I'm talking about. Noticing something we weren't looking for. All my teachers taught me this. I've been learning this since I was a child. Look beyond the obvious to other layers of obviousness. Look at this. We're watching this magnet just stick to this. Okay, let's go to the other side. Let's see what happens over here. Wow. I'm guessing it's going to stick to both sides on both sides. Have you ever seen this? Now here's my question. What can this magnet do? What can this magnet that I just did that to, what can it do in experiments? What happens when we wrap this with wire? What happens when we make an alternator out of this, a generator out of it, a motor? Gosh, it's amazing. I'm so glad I could share this with you. Anybody could replicate this by just having, these are just regular neodymium magnets from Amazon, north on one side and south on the other of each one. And then these little magnets are just little, I think they're just like craft magnets, like refrigerator magnets. One side's north and one side's south. I can't believe this. So can all magnets do this? Once I push them together, and if I can hold them together? I don't think I could do that with neodymium magnets. They're too strong. I mean, I would need a machine. But if Dawn was really getting 50,000 watts out of neodymiums, and I only need 1,000 watts or a couple hundred watts, maybe these will work. And I can do some things like what I just, now I want to do tests with this. I want to wrap this with wire. I want to treat it like a transformer, wrap wire this way and wrap wire this way. I want to do all kinds of different tests with it. That's amazing. Let's see how it behaves with the other magnets now. So this is the one that had the polarity flipped on it, and it attracts to both sides. Let's see how it behaves with these. Okay, it attracts there. It doesn't attract there. Look at that. It's pushing away. That's very interesting. I don't understand that. Because it was sticking to the neodymium magnet on both sides. That was amazing how it flipped the polarity. It flipped it. Yeah, this is definitely not sticking on that side. It sticks on this side. Let's see what the other side does. Pushing away. Attracting. Pushing away. Attracting. Attracting. Oh, it attracts both. Now it's attracting both sides. I don't know what happened. You saw it. I'm showing everything here. So that, okay, let me try turning this around this way. That still works. That still works. What did I change? I think I flipped this over. That doesn't attract. Let's go over here. That doesn't attract. Oh, it's repelling both sides. Whoa. So it repels there. It repels there. Are you seeing this? Is this a mono, what do you call it? Let me see what this says. That's reading south. I like how the night just begins when it was ending. That's reading north. Okay, this is reading north. This is reading south. So what's happening here? Oh, let me set this down and see what this is reading. This is reading north. And this is reading south. North, south. I'll set it down. Okay, north, south. I'll turn it around. South, north. Repelling this way. So let me check this again. So this is reading north, and this is reading north. I guess that makes sense. So it's just repelling. Maybe that makes sense, I guess. It repels both of those sides. I flip it over, and it'll attract on both sides, right? Let's see if all the magnets do that. Yeah. Repel, repel. Okay. So on this magnet, however, on the neodymium, let's see if it's still allowing us to. Yeah, it's still sticking on both sides. I don't know how it could do that. I just don't know what to do with that, but I don't have to know what to do with it right now. I don't have to know. All I have to do is notice it. So it's sticking on both sides of this magnet. Both sides. I don't know what happened here. Let me see. I held the magnet. I held it together. Yeah. Anyway. Okay, everyone. I'm glad I was able to share that with you. I don't know what it means yet, but I think there's something there. Is that what? So if we can flip the polarity of a magnet instantaneously, is that what allows the Don Smith rotating separator coil to work? Is we're flipping the polarity and then flipping it back and forth? Is that when the power comes out of it? But Don was interrupting the field between two sets of magnets. I held two magnets together. I've read of things like this where magnets held together. I think Tom Bearden said something about this. I think he said you can push two magnets. Now, don't quote me on this, but I thought I read something about Tom Bearden saying if we push two magnets together that are repelling each other, and you hold them there, that energy will flow out of that. Maybe that's the test. Maybe what I need to do is take these neodymiums and put a screw through here that brings these together. Brings the magnets together. And then maybe wrap. Let me see, how would I do it? Would I wrap the whole thing with wire or half? I guess I could do both. Or would it just be wrapping the center area where the two magnets come together? These are just experiments. Just thought experiments that may become physical experiments. Okay, everyone. Till the next video. True Zero Emission signing off. Okay.